Hello everyone, welcome to the next lecture of the pre-stressed concrete of the SD3. Now in previous lecture we have seen the pre-stressed concrete post-tension members. Okay. Now in this lecture we are going to see the linear pre-stressing. The linear pre-stressing is applied when the members are straight or flat, means the profile of the cable is straight in the direction of the pre-stressing force. The pre-stressing is called that is the linear pre-stressing. For example, pre-stressing of the beam poles, slab or piles. The profile of the pre-stressing tendon may be a curve sometimes. Here we see the linear pre-stressing of the railway sleepers in the mast construction type. In this way, the railway sleepers are pre-stressed and manufactured. Then next, circular pre-stressing. When the pre-stressed members are used for pre-stressing the circular structures, then it is called as the circular pre-stressing. Especially in case of the construction of the water tank, pre-stressed water tank, the circular pre-stressing is done. For example, circumferential pre-stress of the tanks, silos, pipes and similar products. So here is one photograph which shows the circular pre-stressing containment structure. Then according to the type of amount of pre-stress we are providing, we can also classify the pre-stress, that is full pre-stressing, limited pre-stressing, partial pre-stressing, like this. So in case of full pre-stressing, when the level of pre-stressing is such that no tensile stress is allowed in the concrete, full compression is given to the concrete and zero tensile force, that is called as the full pre-stressing. So under the service load, means whatever the maximum load coming through the life of that particular beam or the slab, in that case that is called the full pre-stressing. Then limited pre-stressing, when the level of pre-stressing is such that some minimum amount of, or we can say that permissible amount of the tension may be allowed in case of the, or for in concrete as per the regulation laid down by the code within the cracking limit of the concrete, it is called as the limited pre-stressing. Then partial pre-stressing, when the level of pre-stressing is such that under tensile stress due to the service loads the crack's width is within the allowable limit, it is called partial pre-stressing. Then uniaxial pre-stressing, when the pre-stressing tendons are parallel to one axis, it is called uniaxial pre-stressing. For example, longitudinal pre-stressing of the beam. Then biaxial pre-stressing, when there is pre-stressing tendons parallel to the two axes, it is called biaxial pre-stressing. The following figure shows the biaxial pre-stressing. In the next slide we will see that. Then multi-axial pre-stressing, when the pre-stressing tendons are parallel to more than two axes, it is called multiple axis or multi-axis axial pre-stressing. For example, pre-stressing of the dome. You have seen the dome structure which is having the reinforcement that when we have to construct it, in 360 degree we have to provide a reinforcement if it is a RCC. In similar way, in case of the pre-stressing, we have to pre-stress the dome in multiple axis way. Then say the advantage of pre-tensioning over post-tensioning are as follow. In case of the pre-tensioning, it is suitable for the precast member or when we produce the precast members in mass construction or for mass production. In pre-tensioning, large anchorage device is not present or not required, we can say that. So disadvantage of this printation is also there. The relative disadvantages are as follow. The prestressing bed is required for the pretensioning operation, means initial preparation is required. Again, the accuracy should be there. Waiting period in the prestressing bed, waiting period in the prestressing or pretensioning is more before the concrete attains sufficient strength. Then there should be good bond between the concrete and the steel over the transmission length. So here is the some of the photographs that is shown how the pretension prestress pretension members are manufactured or casted. Here we see the mold where the molds are there and those are ready to receive the concrete. Also you will say that the tendons here the wires are provided, and at the end the anchorages are provided here so as to tied the wire. Here already this is ready one, and before that this one is there. Okay, so next, here again one of the arrangement of the jacks, how the jacks are used so as to it is initial arrangement of the jack so that the jack can be used to stretch the cables after anchoring into this plate. Initially cables are anchored with the nut and bolt, such type of arrangement or the wedges to these cables or say wires, and then jacks, with the help of jacks, these are stretched. In the second figure here it is seen that this jack is providing somewhat extension or stretching of the strands or the cables. Then here pouring of the concrete process is done. Then steam curing. In case of the factory, for the mass production, generally to develop the early strength in the concrete, the steam curing is done. So here say steam curing, for the steam curing, okay, the member is placed. And this is nothing but the demolded mass production of the sleepers. Then post tension systems and devices. In post tensioning, the tension is applied to the tendon after the hardening of the concrete. That is, some target strength is there according to the grade of concrete. Once that strength is achieved, on that day the post tension is applied. So stages of the post tensioning: one, casting of the concrete, first stage. Then placement of the tendons. Casting of the concrete means after casting some place in the reinforcement itself, the seats are provided or the pipes are provided to receive the cables afterwards. So casting of the concrete,